Welcome to the SEI podcast series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts. My name is Suzanne Miller. I'm a principal researcher here at the SEI. Today, Mike Phillips is joining me to talk about efficient and effective software sustainment. First, let me tell you a little bit about Mike, who I've known for many years. He is a principal engineer here who focuses on sustaining legacy weapon systems that are no longer in production, but are expected to remain a key component of our defense capability, in many cases for decades to come. Not all of them were planned for that long, but we got to keep them going. As an Air Force senior officer, he led an Air Force program office's development and acquisition of the software-intensive B-2 Spirit stealth bomber using integrated product teams, which I know at the time that you did that, integrated product teams were not as big a thing as they are now. So he was very innovative even when he was in the Air Force. Welcome, Mike. Glad to have you here.
Thank you. Pleasure to be here.
Software sustainment. We hear about the long tail, we hear all these things, doom and gloom. Why is it important for DoD systems to be really effective in software sustainment?
I think that's a great question, and it's also a reflection on how things have changed from the earlier days to today. And that being, we now put so much of our capability, we stuff capability into ones and zeros, into software that populates, that is in essence the essence of the system, okay? And then we put it up into the air or under the water or across the desert in ways that the Department of Defense particularly needs to be effective with that system.
And robust.
Robust. So not only do they need to be robust, but they need to be able to keep reusing these capabilities in many different environments and over extended periods of time.
And responding to different threats. The threats change.
Correct.
The environments that we are primarily operating in change. In Vietnam, it was jungles, and Iraq, it was desert.
Right.
So, I mean, those are two extremes. And the physical part of the system has to evolve, but the software part is, as you said, we stuff more and more capability in that because it's the virtual part. It's the part that doesn't have to actually expand in size physically to be able to get more.
And I think for those that are not particularly familiar with the military side of things, we see the same thing happening with our cars.
Sure.
We now have cars that, not many, but it's growing, that cars that will be getting updates.
Oh, I have one of those.
Okay.
I get a USB drive that plugs in, and that's how I do software updates, and I pray that it turns on again when I push that button. After the update, just like computers. But I mean, we are really in the space where we have to worry about all those things.
That's right. And so certainly for many of our systems, we speak of robust, and so part of the advantage that we should also recognize is that our ability to build the hardware sturdily.
Yes.
That's rugged in ways that is pretty remarkable in itself. So, but because of that, we can reuse these older systems. I find it fascinating that one that was created about the time I was born, the B-52 bomber, is flying now and is now expected to continue in operations for perhaps another 20 years. There are stories today of grandfathers saying that they flew something that now their grandson or daughter is flying that airplane, perhaps not exactly the same one, but the same design, many, many years.
Well, and I know of cases. This is in the commercial airspace where you change out the cockpit, which is where a lot of the software intensity is.
Right.
But you're using the same airframe. You're using the same, physical system.
So
underneath. That's becoming common I think the military may have been ahead of the commercial space a little bit
Partly
in terms of
because
having to deal with
that's
that.
right. Because of the other things that had happened around it, that created more of
So
that.
this means, one of the things this means is that the DoD in particular has more experience dealing with this problem than some commercial settings. And
Yes.
you are one of the people that has studied what works and what doesn't work.
That's right.
And that's what the blog post series is about that you've just
Yes.
finished publishing. So give us some ideas about what is it that you observed in successful programs that made them successful in sustaining these long-lived systems.
Well, that might be a point to mention that one of the reasons that I became, there's two vectors that both led me to this point. One was, as you mentioned, my predecessor time in the Air Force was with the B-2, and in that we had 4 major teams all working under one 2-star general. And I had responsibility for the development. However, another colonel, a great peer and friend, was responsible for sustainment.
Right.
And in that sustainment was what became a major site where we now call that particular site the 21st B-2, that there's 20 operational airplanes, and then there's this collection of stuff on the ground that is an integration laboratory, and everything that goes on any of the 20 airplanes must first traverse through that collection of stuff to make sure it's going to work before
it has to work on the
gets into
21st
flight.
airplane before it can go on any of the others.
So that was the one vector. Now the other vector was at the Institute. I've been associated now for a number of years with a thing called CMMI that we've now transitioned out. But in that work, we found that many of the organizations that were actually leading the way in software process improvement were within that domain of sustainment, software sustainment organizations. They were using that to make sure that they had the competence they needed for all of these things that would be transitioned to them from the prime contractors who were going to make the first thing, but they were then going to get responsibility for care and maintenance of that, and often future versions. Now, what gets enhancements, and those enhancements often were not appreciated by those of us that watched the old system, that we thought of enhancements being something, oh, well, that'll be a whole new system. Well, no, it will use often the old hardware system, but for that reason, in many cases, need to be able to be accomplished by, I'll call it the organic side, or the side that the overall system has been transitioned to take care of.
Right. And those, I've worked with some of those organizations too, and they have a huge challenge because they are taking things from multiple contractors and it's been integrated and it's been tested and it's been certified, but as soon as you make any change anywhere in that system, now you've got to understand everything to be able to understand what the effects of that are. So these kinds of sustainment organizations are really the guts of competence related to what this system is really all about.
Correct.
And so being effective in that role is something that takes a lot of time, and it takes a lot of practice and tools and all the rest of the things. So so what are some of the things that distinguish, in your mind, the best sustainment organizations that you've seen? What makes them different from others that kind of just barely hang on?
Well, the ones that struck me, again, there's this correlation, but when the leads of the organizations were in fact champions of change, effective change, they were looking for ways to make their capabilities better. And what that breeds is then people are willing to come work for a place that has that kind of vision.
Okay.
And it seems
so it's back to leadership.
That's right.
Vision
That's right.
and able to sustain
right.
a pace of change.
Right.
of the things that we know are the human things
Right.
that are really
Right.
difficult to
Right.
sustain over a long period
Right.
of time.
So in the collection of the blogs to date have covered the Air Force with several of those organizations that have committed to that kind of constantly taking advantage of the opportunity, okay, to improve how they do things.
Right.
And that in turn builds a collection of capabilities, and we'll be talking about some of those a little bit later as well. But that seemed to be one of those key ingredients for it. And it's not limited to one service. Certainly I kind of paid attention first to the Air Force side because that's where I came from.
Sure, that was your home.
But I've seen the same kind of evidence in each of the services, and that's very refreshing to me to see it. It also is significant that a lot of what I'm seeing there is not limited to, quote, the people that are in the government, but they've often brought in under contract approaches, teams within that help keep that going.
And in the settings that I've seen where that worked really well, one of the things I've seen that I would say distinguishes those organizations is that they're kind of badgeless, in the sense that you may come from 3 or 4 different contractors, you may be civilian, military, you may be military, but no, if I didn't know, if you from looking at your badge where you came from, I wouldn't know.
Exactly
You're just all part of the team for that program.
Right.
And when I see that, that's one of the things that I think distinguishes a lot of these really high-performing organizations that are really focused on the mission.
Yes.
So one instance that you talked about is the Software Engineering Directorate in Huntsville, Alabama, which I also have had the privilege to do some work with. And they are the home, for some of our listeners may not be aware, that is really the source of the predecessor to the Architecture Analysis Design Language, AADL, which is now a Society for Automotive Engineering standard.
Right.
And so this came out of a sustainment need, and it came out of an Army Directorate. So why don't you tell us a little bit about that sustainment situation?
I think that, I'm going to say 2 things about that. First of all, we have some excellent blogs already about AADL and the particular program.
Podcasts.
That's right. And the particular program that I'll be mentioning, the Apache, was within that domain. The reason I want to bring it up from the standpoint of this kind of conversation about sustainment is that where this was being applied was not in essence, a new airplane, or a new helicopter in this particular case, but an evolving one. In fact, what was occurring was that the version that caused a lot of this interest was the D version of the Apache, which is now being converted as a released thing from the D version to an E version because of the software contained, okay? So the intensity of change and the growth in software capability is remarkable. So they're, in essence, retrofitting an existing airframe, okay, the D model, making it then an E model with much expanded capability. Now, what does that mean? How does that get done? Well, that means you stuff the airplane with more new tools, more new ways to work. Avionics is a funny term for a little bit of metal surrounding a whole lot of software. Okay, so in each of these cases, those sorts of things needed to be installed, often coming from very different suppliers. And so where AADL was such a remarkable find was it's a language that sits above the individual pieces and helps you observe what's going on there. And I think what's particularly remarkable now, one of the findings that we've had, AADL always made sense that you need something, an overarching approach to bring architectural approaches into better understandability.
And alignment.
But in addition, we're discovering how well it can assist in things like security and safety concerns. Whereas if you're down at the software level looking at lines of code and trying to discern from that investigation what's likely to happen,
Sure.
it's very, very difficult. So AEDL seems to be helping in many ways. A little bit of an advertisement for having our audience think about AADL. From a sustainment standpoint, it's a recognition that these new ideas, and AADL being one of them, can be employed by groups that we normally think of being at the tail end of the system.
Right.
Oh, well, they won't be leading organizations. They'll be the trailing ones, the followers. Well, that's not the case when you have a technique like this that very much enriches their ability to do their job.
And one of the things that I think AADL brings to the table that is important when you're thinking about evolving a system is that language allows you to have multiple levels of detail of knowledge about different pieces.
Yes.
So the piece that's already built, I have a lot of detailed knowledge about, and I can put that into the language and show what the effects are there. But the new thing that I'm trying to add in, at first I'm not going to have a lot of knowledge about it, but it still allows me to add that into the model, put what I know in, put in my uncertainties, here's the things I don't know, but then it helps me make decisions. And having all that detailed knowledge from the existing product, which is stable, that's a great gift.
It is. It is.
So I think if you haven't thought about AADL for sustainment, that's I think an interesting connection. So you've played with process stuff, you've played with modeling stuff in relationship to sustainment. What other things are you looking at in terms of ways to improve the sustainment posture, both in the military and eventually commercial?
It's intriguing that we've had a couple of challenges that we've been able to respond to. In one case, it was a particular program, the B2, that asked us to look around and look at all of the kinds of the sustainment that was being done elsewhere beyond the one that they were doing at Tinker Air Force Base, is where their site was located. And it was interesting to see the richness of different approaches that were being taken from base to base in the Air Force, okay? And about the time we were doing that, there were a couple of studies, and in the blogs related to this work, you'll see those particular ones called out. We had membership in two of the significant ones looking at sustainment, both of which said we need to start thinking more successfully about software sustainment. And one of the things that often gets missed is that typically when someone says, oh, we're in sustainment, they think about the fact that all of our major systems go through a retrofit kind of process about every 4 to 6 years, something like that. There are those who say that that's kind of shining up the metal and repainting and doing things like that.
Which are all necessary things.
Yes.
It's also looking at metal fatigue, and I mean, there's a lot of things that on the hardware that need to be refreshed and examined, maybe not refreshed, but at least examined.
That's right.
And if you don't change the software, then you don't have that need, but as soon as you make any change to the software, you have a whole bunch of potentially unintended effects that you have to deal with. So that needs a retrofit sort of cycle as well.
The other thing that happens, and that I think does not often get sufficiently appreciated, is that software sustainment has a different role. We don't change software just to polish it up, just to fix it. We change software, in fact, to give us new capabilities. Now, sometimes those new capabilities are because we've encountered a new way of operating the system that the old software did not adequately do. And that would come across as being a problem report.
Sure.
So it sounds like the software broke. Well, we asked
it's really
it to
about
do
the world
something.
changing.
That's right.
And we need to do something new, and the software was never intended to do X.
Exactly.
But we need X now.
Exactly.
So therefore, if the software doesn't give us X, then it's wrong.
Right.
Yeah,
so it is, in fact, there's a term that will probably be used for many for reasons. It'll continue, but we call it software maintenance. But most of the things that get done to the software are not what I think of as maintenance.
Sure.
They're development,
Yeah.
okay? And so recognizing the richness of development approaches, of ways to integrate new and different approaches in, and even, in some cases, to re-architect
Right.
the system. So in the blog, if someone were to read it, you would see a mention of a particular thing associated with what used to be called the multiple launch rocket system. Mm-hmm. But the prime contractor had developed a collection of software modules, and it had grown to the point that there were like roughly 35 modules that all had to work together. Mm-hmm. This was getting to be difficult from a maintenance standpoint to make sure that when you press the button to test it, that everything would
Right.
work out right, okay? So in fact, the sustainment unit that happened to be at Huntsville got challenged with, we need to reduce the size of this thing because the next box that we put this software in is it needs to be smaller. We need to
we need to simplify.
That's right.
We need to look at what we need today as opposed to what we needed 10,
Back
15
then.
years ago.
Right. So now they've refactored all of the software in there down to a size that was about a seventh the size of its predecessor. And in doing that, we've also shrunk the time when the operator goes to say, I've got to do a quick check. That's happening now in a couple of minutes as opposed to 10 to 15 minutes.
So they've improved the performance of the system as
performance
well
is going up in that
simplifying.
sense.
Yeah.
Okay.
And some of our listeners may have listened to another blog blog post podcast that we did about avoiding complexity, avoiding non-essential complexity, and that's a different example of what you're talking about there.
It's all in that notion that a lot of times when we do these things, we say that we're simply trying to get at the heart of keep the same requirements, but we need to restructure it to lead to that more simple approach.
Yes, we need to avoid unnecessary complexity.
Yes.
And that has a lot of effects if we can do that.
Right.
So I think you're going to be busy. I think there are many systems that still have these sustainment issues that you're addressing. And I want to thank you for joining us today and talking about this. And I look forward to some more work in this area, more blog posts and your insights, because I think you bring a very practical side to this that we don't see as often sometimes as we'd like, and so I really appreciate that. So anyway, the blog posts on software sustainment are on insights.sei.cmu.edu, and if our viewers would click on the button in the upper left-hand corner and find Mike's name, which is Mike Phillips, then you will be able to look at all these blog posts and other things that he's written. And wherever possible, we will include links to the resources that we mentioned in today's podcast, which is available on the SEI website at sei.cmu.edu/podcast. And don't forget, we're also on Carnegie Mellon University's iTunes U site. The video of this podcast will also be posted on the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you for listening.